So anytime that you have data that has a normal distribution, you're most likely going to be answering two types of questions. So I'm going to break them down into type A question versus type B questions. A type A question would be a question where you're trying to figure out the probability. So you're trying to find the area under the curve when the x value or the z value is given to you or it's known. So for example, let's say that we're talking about SAT scores, and I want to know what is the probability that if I randomly choose an SAT score, that SAT score is going to be higher than a 1471? So here we are given the x value, 1471. And if I want to know the probability of randomly choosing a value higher than that, then I'm interested in the area under the curve that's shaded in blue, because the area that's shaded in blue contains all the SAT scores that are higher than a 1471. And so this probability right now is unknown. That's what you're trying to solve for. You want to know what's the probability that x is greater than 1471. So if you're using your calculator, you're going to go to your calculator and you're going to press the second button and the vars button. And this is where you would choose the second option. So here you would use normal CDF. So normal CDF will give you the probability when you have the x value or if you have the corresponding z value. The other type of question that you're going to be looking at is if you were asked the opposite. So we call these type B questions. So notice how question B is very different from question A, but still similar. So if you were trying to find the x value or the z value and the probability or the area under the curve is given to you, so here we know the area under the curve and we're trying to work backwards to find the corresponding x value, then this is the inverse of the type A question. So the inverse means if you're going to your calculator, right, you're going to choose second vars again, but this time you would choose the third option, inverse norm. So again, here, this would be a question where you know the area on the right tail is 0.027, and you're trying to work backwards to figure out what SAT score corresponds to the top 2.7%. Okay, and so here on the calculator, you're going to use inverse norm. Okay, so again, you just want to make sure you understand when to use normal CDF, so when to use that function on your calculator, and when to use inverse norm. Now, if you're using formulas, then for type A questions, the first thing that you need to do is convert that x value to a z-score. So the formula that you would use would be the formula for calculating a z-score, which is x minus mu over sigma. Now, if you are trying to answer a question like question B and you want to use formulas, then the first thing that you need to do is go to the Z table, search for the area that is the area to the left of the blue region. So that area would be 1 minus 0.027. That will give you a z-score. Once you have the z-score, and then you have mu, and you have sigma, so you have all that information, you can use the formula for calculating a z-score, but here you're going to solve for x. So that formula is going to be x is equal to the z-score times sigma, the population standard deviation, plus mu, the population mean. So you can use this formula, right, to find x when you know the area under the curve. So I hope this helps you break everything down for section 6.1 and 6.2 and understand when to use normal CDF, when to use inverse norm, and then also when to use the formula for z equals, and then when to use the formula for x equals.